Still painful. So today, you know how like there's the spiritual realm and then the physical realm, and we're like all just chilling out here, and then like there's like angels doing all sorts of warfare, and like all that's happening, right? And like if you truly believe the Bible and you're like, okay, cool, there's this whole other realm that's happening right now in this place that we don't even see, right? And then you read Daniel and you're like, how could the archangel Michael be like detained by a demon? Like he was like battling it, like he heard Daniel's prayers and he was like, okay, cool, I'm on the way over. And then like demon comes in and like gets in the way, right? You guys read that, right? And it's like, how is that even possible? Because there's stuff happening behind the scenes that we don't understand, okay?
That'd be so cool to see.
That would be really cool and scary.
Yeah, that makes me think the best.
Yes.
So, in math, we also have like an imaginary realm that is like behind the scenes that has always existed, but we've never talked about it until now. So, when you take the square root of something, you usually get two answers, right? Like if x squared equals 4, then x equals 2, but it could also equal what?
-2. 4 to square root.
-2, right? Because -2 times -2 is 4. But when we take the cubed root, we usually say there is
Just one.
Yeah, just
one
-2.
solution,
Just
right?
-2.
Whoever told you that lied to you.
Huh.
There's actually 3.
Oh no.
But the other 2 are imaginary. And by imaginary, I really don't even mean imaginary. You've actually already stumbled upon this issue. The issue is, and I think the other roots, if I'm not mistaken, are, oh man, can I do this in my head? No. Sorry, this is all pre-calc, so you don't have to actually know this yet, but you will. What is that? 1 plus square root of 3i and 1 minus square root of 3i. Okay, there we go. Is that right?
Oh no.
Yeah.
180, 270. How do you know? You don't know pre-calc.
Well,
You're like, oh yeah, that's right.
Because the I
That's-
remember the I from the book. The I means like negative.
I'll buy that. Okay, so those are the other 2 roots. Notice that I've used an I. The I denotes that we are no longer in the real numbers. Okay, remember that little chart from like the beginning of whatever, like 5th grade math, where they're like, these are counting numbers. And you go like 1, 2, 3, 4. And then you're like, and outside of counting numbers are the whole numbers, right? And that includes 0, 1, 2, 3. And then outside of the whole numbers, you have the integers,
Oh yeah, -1. Yeah.
and they include negatives,
Positives. And 0.
and then outside of that are the rational numbers, and those are numbers that can be written as a
The decimal number?
fraction. So a fraction of integers gets you rational numbers, like 1/3, even though it goes on forever, it's still a rational number. And then outside of that, all the weird stuff that we don't talk about, like pi or the square root of 2, those are all
Irrational.
in the
It's a separate.
Then we have this weird like thing growing on it called the irrational numbers, like square root of 2, pi, square root of 3, ugly things, right? That don't repeat. And then inside all of this is the real numbers.
Real.
My teacher really draws
Mr.
that.
Bonner, do you remember your
Unfortunately, that's not the full story.
Oh no.
No way.
Because if you have real, you must have
Fake, artificial.
unreal, right? In this case, we will call them the imaginary
Imagination.
numbers. Those are numbers that have I in them. And we'll talk about what I is in a second. And all of these make up something called the complex numbers, which have real and imaginary parts. So, up to now, your vision of mathematics has been this half, right? You've seen this, you've kind of worked with it, all the rules that you've learned have to do with this half. Well, now I am adding a new area of mathematics, okay? This is all new. This is like, you get a newspaper and you're like, whoa, just discovered. I've never seen this before in my life. Everything else, we're just like building on the same stuff. This, brand new, okay? So, when we have imaginary numbers show up, we will always have complex numbers, okay? So we'll never just have imaginary numbers. We will always have complex. So now, instead of dealing with real numbers, which is what most of your problems do, we're going to add, anytime we see imaginary numbers, we're going to work in the complex numbers. So we get to use all of these now. So when we're in that, complex numbers have two parts. They have the real part and the imaginary. And you have to remember that. They're always separate. You have the real part, you have the imaginary part. So the real part may be 2, right? That's a real number. Imaginary part might be 3i. Or in the examples here, I gave 1 plus the square root of 3i was one of my examples, which is a cubed root of -8. So, what is I? You've actually stumbled upon it already, and I've told you that it is not allowed. But in the complex numbers, it is allowed. It is, it's actually really simple. I is the square root of -1.
Wow. Oh, that's a nice.
You know how I was like, no square roots of negatives, and you guys were like, ah, and I was like, no, and then you guys were like, ah. Well, there are. Sorry. So there are square roots of negative numbers, and in order to take the square root of a negative number, we must be working in the complex plane, where we have the real part and we have the imaginary part. Okay? So, that is that. Now, let's talk a little bit about why these things exist. Or do you want to just, let's try some problems. Yeah, we'll do that. Okay, so how would I write the square root of -13? Well, I'm going to write that as a complex number, so it has a real part and an imaginary part. The real part is 0. The imaginary part is the square root of 13i. So anytime you see a negative in a square root, you take it out, put I there, and then leave the rest. Sound good? Let's try the square root of -4.
Wait, can you repeat that again?
Let's see if you can get it from these examples, then I'll come back. Okay? Square root of -4. I'm going to take the negative out. That becomes I. So that would be the square root of 4i. Okay? Is there any real part to this number?
No.
No. The only part we have is the imaginary part because it's multiplied by I. So it's going to be 0 plus the square root of 4i. Now, Jose's not satisfied with that. He says, absolutely not. I refuse to leave the square root of 4 on my paper because the square root of 4 is 2. So the square root of -4 is 0 plus 2i. Real part, imaginary part. Okay. Once you deal with the fact that I is the square root of -1, you can treat I just like a normal variable, okay? So you can add like terms, like all of that good stuff still works, okay? Let's try another one. What's the square root of 3 times the square root of -2? So, what do I do first? The negative has to become an
Imaginary.
I. So this is the square root of 3 times the square root of 2, I. Now what's the square root of 3 times the square root of 2?
6.
Square root of 6, right?
Yes.
Because you simply multiply the numbers inside. So this is 0 plus square root of 6i.
Question. Is the I included in the square root?
No.
Okay, so you're multiplying it times I.
Mhm.
Okay, so make sure not to include.
Okay. Now, what happens if I have this? Two possible answers, right? 3 or negative 3. Which one is it?
3.
It's going to bother all of you.
Oh,
Which means it's negative 3.
no. Oh, no.
Why is this negative 3? Because a square root is saying what number times itself is that. Right? So if you multiply that times itself, you should get that thing out.
Oh. Oh, so it's basically negative 3 squared. Yeah. Oh, duh.
Right? That's a good way to put it. That's going to be negative 3. You're like, but the squared should get rid. It doesn't. Why? Well, because technically what we should do is we should pull the I out first. Obviously the square root of 3 times the square root of 3 is the square root of 9, which is 3. What's I times I?
I square.
So this part is 3.
No. Oh, it'd be negative 1.
It would be negative 1.
Oh.
Why? Because if I is the square root of negative 1, I squared is the square root of negative 1 times the square root of negative 1, which we already said is negative 1.
Oh, my.
Yes?
So wouldn't it be negative 3?
Yep.
Yeah.
So I squared is negative 1, so it's negative 3. That was my build up. The suspense was ruined.
Okay.
That's okay though. That's fine. I always like to point out mistakes when the teacher makes a mistake. That was my favorite thing to do. I ruin their suspense occasionally. Occasionally I was also wrong.
Only occasionally.
Just once. No. All right, so, well, this begs the question, what's I cubed?
1.
What's negative 1 times I? Negative I?
Oh.
Would that be positive since?
Nope,
no,
definitely
because
negative.
Square roots are, I mean, dumb.
It's because it's negative.
Okay, how about this? What's out of the fourth?
No.
I-
No, it'd just be 1. Positive 1?
It'd be I.
Well,
Well,
it'd be
negative I times I would be negative I squared.
He's with the food, but I don't know if I can.
Okay, I'll deal with it. Thank you. So that is 1. Because I squared is negative 1. So you get 1. All right,
Would that be a negative 1 or a 1?
it is 1. Now, your job for the rest of this is to find I to the 5th, I to the 6th, I to the 7th, I to the 8th, I to the 9th. Go.
Well, I thought it was the same pattern if it was gonna be another I, so it doesn't get opposite.
Yeah, I'm just making up my own after.
This is I to the
I'll send it to you right after. So this is probably
Yep, dude, I round.
I mean, that's that.
Sure.
Square root of negative 1 times square root of negative 1 times square root of negative 1 times
There's a one dot.
cancel each other.
So basically negative 1 becomes negative 1 becomes negative 1.
Is it negative 1?
No, square root of negative 1 times square root of negative 1.
Those two cancel each other out by making it positive square root. Oh, no. So then the Positive I. Okay, so what would I find?
Then why didn't they be like
Do you want me to explain it to you?
So you're just
No.
multiplying
Do you want me to like explain it?
Yeah.
I to the fourth times
So this is like I to the fifth, right? So square root of I to the fifth. So that means that is going to be -1.
Alrighty, so by this point, you should have noticed that I to the fifth is I. I to the sixth, well, it's the same as I times I.
That's what I was saying. I was like, well, then it could be a
The pattern repeats every 4.
Alright, hold on.
So, I, we just leave it. I squared becomes -1. I cubed becomes -I. I to the fourth is 1. Then you repeat. I to the fifth is I. I to the sixth is -1. I to the seventh, -I. I to the eighth, 1. I to the ninth, I. I to the 10th, -1. I to the 11th, -I. I to the 12th, 1. And it repeats over and over and over and over again. Okay, let's actually do some problems now. And see if we can get this. So we have the following. 2i minus 7i plus 2i minus 4 minus square root of -3. Okay, our first step is going to be to get rid of all the higher powers of I. I want it simplified down all the way to just i's or no i's. So what is I squared? I squared is? So this becomes -2. I want you to show this step. I know you feel like you can skip it. You know who you are. Step skippers.
I'm not a step.
Show, God bless you. Show the first step, then plug in so I can see what you thought was correct. Okay? I cubed is
I.
-I. So this becomes plus 7i. 2i stays 2i. I don't deal with the single power of I. Minus 4 minus, what's the square root of -3?
3i.
Square root of 3i. Now, our final step is we are going to combine like terms.
I know, but.
So,
Because he does first.
so we have, this one doesn't have an I, and that one doesn't have an I. -2 minus 4 is,
-6.
this one has an I, this one has an I, and that one has an I. So this becomes 9 minus square root of 3i. You have to write it that way because, remember, each complex number has a real part and an imaginary part. You have to separate the two. So this is the real part, right? You would see that normally, but this is the imaginary. Imagination.
So you have to make that different.
Yep. So you always separate the eyes by themselves. Okay, and that is your lesson.